Hi, I'm Daniel McCarthy, and for our university project, we've decided to make a cube that can control your household appliances. Now, in the assignment brief, I'm required to show the code, so let's do it. So up here, we're including Shark. Shark's a library I developed for our smart cube, and it contains a protocol that's built on top of Bluetooth as well. This memory-free library was just used for some debugging, which I forgot to remove. Okay, so down here, we're including the libraries for the gyroscope, the thing that measures the movement of the cube. And here's our liquid crystal display. And we have button definitions here for our up, down, and enter buttons. And they use the analog pins A0, A1, and A2. Here we hook up our LCD display on pins 8, 9, 10, 11, 12, 13. These are our options. On the LCD, when you see the options, these are the main menu options. And we only have two, start, scan, and about. Okay, and we have a current option integer here. And using these two, we can choose which option to display on the screen. Here are some definitions. The Smart Cube ID, this is the Shark. This is the Shark identifier basically for this Shark device. Okay, so it gets a bit complicated down here. We have some temperature code. Originally the cube could sense temperature, but we just didn't have enough time to implement it into the electronics. So the functionality is still here, but it's not completely implemented in both the code and the hardware. So here we're making a bunch of Shark devices. Like I said, a Shark device is like the cube, the plug, anything that is Shark compatible is a Shark device. Like I said, the Shark is our protocol basically. So down here we initialize Shark. We give the name of the Shark device as Smart Cube. We give the Smart Cube ID, the build. These are the Bluetooth pins. No, these are the serial pins to communicate on. Our Bluetooth uses serial connection to work, so 6 and 7. Now here we pass a read function and a write function. The write function never got implemented. We didn't really need it, and it could be used for future purposes, so there was no point removing it. So by here is our read function. Now basically you need to it's down here. It was declared up there, but it's down here. Now basically the point of this function is when another Shark device asks you for a component value, your Shark instance will call your read request function, which you've told it up here, and then it'll then, yeah, still recording. It'll then call it. It'll pass the component ID, and it will pass a pointer to the buffer. Okay. Now, basically, the component ID here, we're basically saying if the component is the gyroscope and the AY is above 15,500, then the result must be gyroscope tilt left. And it does the same sort of thing for all the angles, and these will actually be different in the main hardware now. So the cube will think it's like left when it's actually right or something. But the reason for this is because the way we've positioned the gyroscope is now different. But the same concept exists, so there was no need to really change the code at that time. So down here, anything we set the buffer to in this function, anything we set the buffer to will basically be sent to the Shark device reading from the component. Okay. So down here we start the scan. Okay. So this is the start scan function, and it basically prints scanning to the LCD. It'll call shark.scan, and it'll pass the pointer to a device array, the Shark device array, which we saw up here. Okay. So it'll pass pointer there. So then we're basically saying Shark, scan for devices and store them in our device array. Store the total devices you found in the total devices available variable. That's what we're saying here. We're passing a pointer to a variable we want for them to store the total devices they found. And here we pass the maximum devices definition, which basically we don't want the cube to bring back more than we can store in the array. Now, if I had more time, I would have changed this so it would dynamically work with it instead, so there wouldn't be any limits. But of course, as long as you keep this definition quite high, like 10, in a real scenario, it's unlikely there will be 10 devices you can control within 10 meters of each other. Okay, so okay, cool. So this is the debugging functions we were using when we were having some problems. But like I said, I haven't removed the debugging code at the moment, so it's still there. It's not used. So this is our about function, and basically all it does is it just displays the build number and the date it was finished, and delays for 4 seconds. So it's basically like an option, so it gets called when you select an option. Now here's our main menu process selection. This was made by Rabia. Basically the main menu is pretty much completely made by Rabia. And we pass the current option, and we check if the case is 0. So basically, if the current option they've selected is start scan, then start the scan. That's basically what that translates to. Here we have case 1, and case 1 is obviously the about. So let me show you up here. This is case 0. This is case 1. Okay, so 0, and then that would change to 1. And this is how we can tell which option is selected and which option we're currently on, So scroll down here. Okay, so now we're at the setup function. So here we just set up our pins, the up button, the down button, the enter button. We start the LCD display with 16 columns and 2 rows. We print Smart Cube version 1.0. We go to the next line and just write by Dan Rabia. So here we initialize the Shark protocol. We've defined it further up as I showed earlier in the video, but now we need to initialize it. So we initialize it here, and we tell Shark what components we own. So we own a gyroscope, so that's what we've put down, and that's pretty much the only component we want people to be able to request at this time. Maybe the buttons could be a thing in the future. So Shark component _r, that basically means that this component's readable. Again, in the future we've written the ability to write, but it isn't fully implemented. So this is why this was used originally, because we were going to have it so you can write values to components as well. But to future-proof things, it made more sense for other devices to read values from the cube. So here we start the the wire. I'm not pretty sure what that does because this is code that we found online for the gyroscope that we are using. So in our loop method, we get the current raw data from the gyroscope and we store it all in these variables here: AX, AY, AZ, GX, GY, GZ. Okay, and this will be used. This gets used up here, as you can see. Remember before? AY, AY, AX, AX. This is where, you know, another device, when they request a component from you, this function gets called by your Shark instance, and it'll pass the gyroscope ID here. So it'll go if component is gyroscope, which it should be, and then it will determine whether it's a tilt left, a tilt right, a tilt back, or a tilt forward, and it'll send that to the requesting device. So okay, back in the loop. So here we process Shark. Now this basically I gotta search, it's quite a lot of code. This basically checks if we're currently connected to a device. If we are, it'll process that connection. Okay, so then in there then it'll check if the time since they last had a ping is above 10 seconds, and if it is, it'll disconnect from the device. Now the reason for this is because let's say there's a power cut in one of the devices, the cube will be constantly connected, and this isn't good. So to fix this, it made a lot of sense to have it disconnect. Obviously you press the disconnect button, it'll disconnect, but we also needed a way for devices to know that they were disconnected. Maybe you cut the power of the cube while the device is still connected, and now you have to reset that device. So it made a lot more sense just to make a disconnection detection, which is exactly what we've done here. So when the Shark connection is getting processed, it'll first process the output, okay? And this basically checks if we're queryable. Now, if you're the reason we check if it's queryable, because you might just be doing a scan. You know, you might just want to know what devices are in range, and you know, you don't really want them spamming you, asking you for device information, because you really don't care. So this is specified in when you connect to a Shark device, and if you're searching for devices, process Bluetooth will never get called, it'll just return here, you know. So what we do in here, we check if the last time we sent a ping, you know, the thing that says that we're still connected, is above a second. So if we haven't sent a ping in a second, then send a ping. That's basically what that translates to. And then we process the Bluetooth input, and we basically check if we have any data available, then read in an operation code. Okay, the operation code is like a request, you can think of it, okay, or like a state, you know, like I'm ringing the doorbell, I'm picking up a bucket, you know. So opcode 1 is basically the device. When we receive opcode 1, the device is saying, give me a component value, okay? And it'll also send the component ID. And then what we do is we check the component to see if we can find it in their connection. We received all this device information upon connecting, by the way. So what we do here, we check if we've received it, okay? Well, no, sorry, we don't check if we received it, we check if the component exists, okay? Because, like I said, when we connect to a device, they exchange device information, so we know every component that is registered on that device. Anything we connect to or connects to us will know that we have a gyroscope, but they wouldn't be able to connect to us because the code, um, we basically haven't allowed that. We'd have to call the accept method for that, which we're not doing. We're only calling the connect method. So once we've got the component, we just initialize a buffer on the stack, okay, with a maximum value length, and then we check if the component's readable. You know, oh, I'm sorry, I got that wrong. We check our own component. Okay, we check our own component. We don't check their component right now. Right now we're checking our component because they're requesting from us. So, for example, when they request the gyroscope from us, they'll pass us the component ID of the gyroscope. And we'll be like, yeah, we got it. And then we'll check if it's readable. Okay? Now, if it's readable, we will then call our read method. No, their read function that was defined up here at the very beginning by here. You know, the function they passed us. So we'll basically call it and pass the component ID, and we'll pass a pointer to our buffer as well. But then we then send the component value to the peer. We do this by not responding directly, but by sending an operation to them. So we go bt write to bt write component ID, and then we write the entire buffer that we've allocated here. Okay. So now they'll obviously be here now. They'll be here, you know, operation 2. They're receiving a component value. So what'll happen now is it'll read in the component ID, and it'll get our device. Okay, it'll get the peer device. So this is the cube now. Okay, this device here is reading our cube to see if it has the gyroscope that it's talking about. Okay. No, not to see, actually, to set its bytes. So once it's done that, it'll read in the bytes into its value. I understand by looking at this code there's a lot of things that can go wrong, but we didn't really have much time, and this is just a prototype. Like by there, I should have checked by here if it was null and not did anything if it was. But yeah, that's my bad. And again up here, right, no, okay. So yeah, again up here, I should have checked if it was null again, because there's possibility of a memory problem here, so we need to. We don't want any null pointer problems. Okay, so opcode 3 is for disconnection. If we receive this, it'll disconnect our connection. Okay, basically anyone sending opcode 3 is basically saying, yo, where I gotta go. You know, that's basically what it's saying. And what will happen when the disconnect is called? Hold on. Right, what will happen when the disconnect is called is it'll change it'll change our connection status to false, okay, because we're no longer connected. So we'll go this connected equals false, you know, we're not connected anymore. And now if they're the connector, the person who connected to the device, and they have a blue Smurf Bluetooth module, then they need to kill the connection. It's important to do because otherwise, you know, there's going to be delays with disconnecting. It's going to cause other problems. It's going to be stuck in a connected state. I mean, imagine if it's already connected and the cube mistakes and tries to connect again to something else or the same device. It's going to cause some problems. So this is important. So yeah, the last one is a ping, obviously. Basically, every time either peer sends number 4, it'll basically update the last ping status, which is important because like we don't want it to just be stuck thinking it's connected when it isn't. Okay, brilliant. So I've talked about that. So let's go to this part. Okay, so here we check if the shark is connected. You know, have I got a connection? Now if you do, it'll print out the device name. Okay, it gets the peer device, gets the name, and prints whether it's connected, and prints that it's connected. Now if it isn't, and we're currently listing devices, this is like after a search, okay? It will output the current option that we have selected, basically, okay? If it isn't, then we're clearly on the main menu because it's neither of those two, so we output the options here. Now ideally, I should have written a library for this, and it would have made it a lot more sense. Maybe I could have a menu handler or something, and it'll be much cleaner code. But we just didn't have the time, so this had to do. So here we check if Shark isn't connected, okay? Now if Shark isn't connected, and we're listing devices, and there's another option available, like ahead of us, then we want to go to the second line of the LCD and print out the second device name. Now this is so it lists the first device we see and the second device available to us. Now if we're not listing devices, then it's pretty much the same thing, but we're on the main menu. So here it will set the cursor, it'll check to see if there's if there's another option. And if there isn't another option from our current option, you know, if there's not one below us, no, if there is one below us, I mean, then it will print it. So this basically makes it so on the first line you have the current option you selected. On the second line you have the next option that you can select. So basically here we check if Shark isn't connected. We check if the down button is high, okay? You know, if it's pushed down, basically. Now if it is pushed down, we need to check if the current option doesn't equal, if the current option -1 doesn't equal -1. Now this is basically to stop someone trying to go up when they can't go up anymore. You know, I mean, this could cause serious memory problems if this code wasn't here. So down here we go else, you know, so basically, there is more options that above us. So no, sorry, that's what that says there. So yeah, if there's more options above us, current option minus, which will basically just push us up the list more, you know, so we can go up through the options. Now if we can't go through anymore, what happens is it loops around, okay? I mean, if we can't go down anymore, my bad, this is for going down, not up. So if we can't go down anymore, then it will basically loop back around, so you end up on option 0 again. Now here's the up button. Sorry, it's my mistake. So we check if we're listing devices. If we are listing, no, we check if we're listing devices. If the current option we're on, no, if the current option we're on +1 is below the total devices available, so this basically means is there an option above us? Okay, so if there is an option above us, then current option ++. else current option equals 0. Now I may have got these the wrong way around. I'm pretty sure this should be the up button and this should be the down, maybe. I'm not completely sure, but it seems to be working, so hopefully it's right. So here then, so here we're saying if it's the enter button that was pressed. No, hold on. Sorry, my bad. Basically what we're saying is, down here we're saying if we're not listing devices and the current option +1 is below the total menu options. So this is for like oh yeah, I guess, yeah, this is for going down the LCD, but I've called it up for some reason. Okay, so then we delay each time by here as well, by the way, because we don't want them to rapidly go to the LCD by holding the button too long, you know. So here's the enter button. Now what we do is if we're listing devices and the Shark protocol is connected, then we need to close the connection. That's what we've done here. Now if we're not connected, then we need to connect. So we call shark.connect and we connect to the Bluetooth device of the Shark device. And obviously we check if it's connected or failed. And down here we just process the main menu selections if we can. Yeah, if we're not listing devices, we just process the menu options. Okay, so I'm just gonna quickly show you a few more things and then we'll wrap it up. I've got too much code on here to talk about and it's due at 11:59, so I need to hurry this thing up. Here's our scan method, and it basically just uses the blue smurf, loops through it all, sends anything it needs. Basically starts an inquiry, checks if it's found anything. If it has, it'll list all the Bluetooth devices. No, it'll read in all the Bluetooth devices, you know, Bluetooth ID, Bluetooth name, and it'll store them in a Bluetooth device which I've declared in the header file. And we can then access that here. So then we try to connect to the Bluetooth device, and if we can, we make a Shark device, and then we set the Bluetooth ID to it. And then the thing is, we allocate the Shark device. The Shark device, when we go get peer device, it returns a pointer to the Shark device. So because of this, I copy all the memory instead, because otherwise whenever this connection is ended, we'll have a really bad pointer in the array, and we really don't want that. Yeah, so it made more sense to have the actual structure rather than pointers to these devices. Okay, so then we close the connection. Now this false thing here, earlier on the video, remember that is queryable. This false thing means that it isn't queryable, because again, we're doing a scan. We don't want them asking us for information. It's going to cause problems. Here, so when we're finally done, we set the total devices available. Remember the variable that they passed us, the pointer? So we set that to the current index because that was the last index, so it would be the count. Now down here, this is for connecting, obviously, and it sends C, and then it will basically it'll connect to it, and then it will call the connect function again, but this is a different type of connect function. It has different arguments. It basically just passes whether it's queryable or not, and then that will send some other information, and it will receive the connection, and it'll send its own connection, and whether it's queryable, it'll receive their connection and set itself as connector. And yeah, this is the accept. So whenever the accept is called, it'll be on a constant loop, just waiting for some data. Maybe I should have changed this, but it seemed more practical for the situation we're in. So this basically just reads an identifier. Every Shark device sends an identifier and receives an identifier, just to make sure that they're talking with a valid Bluetooth device that has the Shark protocol. So when we read in the identifier, if it's correct, we send our own we send the same identifier to tell them, yeah, this is us, and then we receive their connection and then send our own connection, and then we set the connection to this connection. Okay. So yeah, I could talk about this a lot longer. So I'm just gonna wrap some things up in three minutes. Okay, I had to modify a lot of stuff in the core Arduino libraries, well, some stuff, because they just simply didn't have it, which is quite shocking. Down here, I had to add the ability to write integers to streams, no, to the print objects, because they only have ability to print ASCII numbers and all this rubbish, and it just didn't make sense logically to do that, because you're sending an ASCII number when you should really, it makes more sense to send the number as a decimal. So here I basically take an integer and I just send it using bitwise logic. I just shift it 8 bits. I shift it 8 bits to the right, and then okay, I lost where I was because I had to pause the video, so I'll just say it again. By here we're using bit shifting to send the data across integers for both 16-bit and 32-bit. That's what I had to add in the print class. So I obviously had to add the same in the stream class for receiving. So down here we receive 2 bytes, and we shift the first byte 8 bits to the left, and we OR it with the second. This essentially joins the bytes together in a bitwise manner. So we do the same for 32 bits. So that's what I had to modify in the print and stream classes. I can't believe they didn't already have it. I think it's because they're mostly focusing on like printing to the screen and stuff, and sending ASCII data, but we didn't need that. It made more sense to do it this way. So yeah, they're the ones I had to modify, and yeah, so oh yeah, I had to modify another thing as well. The buffers for the hardware serial, they weren't enough. They were causing me serious problems. So I'm on the wrong one here. Yeah, so I had to modify the buffers. I just modified them, made them higher, and that solved that bug, because we were having memory leaks at one point because there wasn't enough room in the buffer and it was causing problems. So yeah, I could go on. I mean, I got a lot of files to show, but running out of time. So yeah, this is the code. So I hope you liked the video. We've worked very hard on this project. We've had a lot of sleepless nights. So yeah, I hope you found this video interesting. Thank you.